Okay, this is 6-1, part 2 for 5th grade. We're going to talk about multiplying and dividing by powers of 10. And if you're sitting there and you're saying, I already know this rule, you take whatever the power is and that's how many zeros you add, I'm going to tell you, very true, good job. However, there's a catch. That rule only works for whole numbers. So today we're going to talk about how do we multiply by powers of 10 when we're using fractions. And not only that, if we can learn how to multiply decimals by powers of 10, then you can just as well learn how to divide them. They go hand in hand. So first, let me show you the old rule. When you have whole numbers, whole numbers obviously just mean regular numbers with no fractions or decimals. When we have whole numbers, it's really just a matter of, let's say 6 times 10 to the 4th. A lot of you are trained to know, that's going to mean we need to take the 6 and add 4 zeros. 1, 2, 3, 4. And boom, you've got 6 times 10 to the 4th power, and it equals 60,000. Okay, so that works for whole numbers. Now here's the decimal way. Here's what we do. So I'm going to underline that. The decimal rule, I'm going to make it quick. We could really drag this out if we wanted, but I'm going to give you the quick hitter. And I think we could sum this up by saying, instead of adding 4 zeros, you're going to move the decimal point to the right by the number shown in the exponent, shown as the exponent. I'm going to clarify that this is multiplying first. So if you're shaking your head and you're like, I have no idea what that means, what are you talking about? Then the best thing we can do is get right down to it. So instead of using a whole number, we use 6 for the whole number one. Let's turn 6 into a decimal. Let's call him 6.2. So what if it's 6.2 times 10 to the 4th power? What do we do there? Because if we follow our old way, we're going to end up with the wrong answer. We're going to end up with maybe 620,000 possibly, and that just won't make sense. So let's take a look at our definition and then look at our example here. To multiply a decimal by a power of 10, it says move the decimal point to the right by the number shown as the exponent. So the number shown as the exponent is 4. So that means we're going to move this decimal point here over 4 place values. So I'll show you here. I'm going to put our 6.2. I'm going to write the decimal a little bit lighter because he's going to be moving. So if the exponent is 4, we need to move our decimal 1, 2, 3, 4 places to the right. So his new home is going to be at the end here. And do you guys know what's going to go in these empty little clouds? Every time we see I don't know what you want to call that, a cloud area, space thing, we're going to put zeros inside of every little cloud opening there. So your new answer should be, I'll rewrite it, 6.2 times 10 to the 4th. It's actually 62 thousand. And we know if it makes you happy, you can put the decimal at the end, but if there's nothing going on over here, you don't need him. He's just imaginary. We know that that's where the decimal would be, but we don't have to have him. So why don't we take a look at our actual page? Long story short, multiplication equals move decimal right. So let's take a look. We'll jump right down to number 2. You can come back and look at number 1 on your own. That's a reasoning question. Down here, they want you to use a calculator, they say, to complete the table. And it says, look for patterns in how the decimal point moves. You don't actually need a calculator here, guys. You can follow the rule that we just made up a moment ago. Or we didn't make up, we discussed. I did not invent that. So with 4.53 times 10 to the first power, all you're going to have to do is move that decimal point one spot, and since we're multiplying, it's going to go to the right. So 4.3, it's basically, when it's just 10 to the first power, it's like 4.53 times 10. So if we move that decimal point one spot over, you're going to end up with 45.3. And what direction did our decimal move? Yeah, you bet. Move to the right. And how many places did we move it? Well, we know right here it told us to move it once. So we only moved one place. Okay, and so you're going to go through this entire table and you're going to look and see what the exponent is. If it's 2, that means you're going to move your decimal point 2 places to the right. If the exponent is 5, you're going to move your decimal point 5 places. Now, maybe I'll point this one out for you real quick, just as a second practice. Sometimes I need to write out the number in its original form. In fact, a lot of times I have to do this. I do 4.53, and this is why I use pencil, by the way, for math class, when possible. Our exponent is 5, so that means he needs to move 5 places. And since we're multiplying, it's 5 places to the right. So we're going to go 1, 2, 3, 4, 5. Now hopefully on screen you can tell, and you can see these little clouds. So our new decimal will be at the end here. And what do we put in these empty clouds? Yep, zeros. So your new number, when you do 4.53 times 10 to the 5th power, I'm going to move that 4 a little bit closer, you actually end up with 453,000. We move to the right, and we move to the right 5 places. If this is shaking you up, if you're not quite sure about it yet, you can use a calculator to double check. The Google calculator, if you don't have a scientific calculator, the Google calculator has an exponent button. It's on the bottom row. It looks like an X with a number up next to it. So you can go a couple different routes there. Now, I'm going to show you the division one. I think it will go quicker because you're going to notice a pretty neat pattern. So let's shift over to page 197. Okay, so you're going to notice that we have a very similar table. Instead of 4.53, we're now dealing with 67.2. Can I show you how to do this in like one quick sentence? Remember how multiplying decimals by the power of 10 meant moving the decimal right? Well, dividing decimals by power of 10 means you just move the decimal wait for it, dot, 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 left. Oh my gosh, that is hardly legible. Okay, so multiplication, you move it to the right, and then division, you're moving it to the left. So I'll show you a quick example. 67.2 divided by 10 to the first power. All that means is you can put your test one down, how it's originally written. Remember, there's going to be some erasing involved. Here's the original. And since it's divided by 10 to the first power, this tells us we're going to have to move the decimal one place. And since it's division, we're moving it one place to the left. So take that decimal, move him one place over. So the new number after you get rid of this decimal is no longer 67.2. It's actually going to be 6.72. So in this case, instead of going to the right, we're going to the left. And we went over one place. Now again, you're going to use the same strategy. If you end up with empty clouds, if, for instance, when you get down here, you're going to start going beyond the 6. You're going to end up with empty clouds like this. Do you know what you put in those clouds? Same as the multiplication. You're going to fill the empty ones with zeros. And then there'll be a 672. I don't know if that's right for that one or not, but I just wanted to give you an example. I'll add one more note. In this case, when you move the decimal left, it's not going to be optional. Do you know how I told you if you wanted over here, you could exclude or get rid of the decimal at the end? That's not true for division. You need the decimal at the beginning. So even if you go way over here, you still need to have that decimal written down. Okay? So the only big difference between dividing by powers of 10 and multiplying, number one, it's going to be the direction. Multiplication to the right, division to the left. And number two, for division, you always need that decimal. Whereas with multiplication, sometimes you can just leave it as an imaginary decimal when you're done. Okay, if you have any questions, of course, as always, hit me up, email me, dojo, comment, whatever works. All right, guys, hope that helped.